Okay class, so let's start for the next topic, that is the color code for the carbon resistances. We have a color code to calculate the carbon resistances. For that color code we have to remember a table. For the table, first we have the letter, then we have the color, then we have the figure, multiplier, again we have the color, and again we have the tolerance. How we write the colors? This is black, black, brown, red, orange, yellow, green, blue, violet, grey and white. We always write the colors in this series. And how we letter means first letter. R, O, Y, G, this is Y, G, B, V, G and W. So to remember this, we can say B, V, Roy, Great Britain, very good wife. So these colors must be written in this series. And in figure, we write the number 1, 2, 3, 4, 5, 6, 7, 8, 9. And in multiplier, powers 2, 3, 4, 5, 6, 7, 8, 9. Here we have the three more colors, that is gold, silver and no color. These are the tolerance 5%, 10% and the 20% tolerance. Now how we calculate this color code? We have the carbon resistor. We have three colors here. एक last pair A, B, C, D. Give the name of colors, like this is a brown color, yellow color ਦੀ strip ਆ, ਇਹ black color ਦੀ strip ਆ, या black ਦੀ ਬਜਾਏ ਇਹ brown color ਦੀ strip ਆ, and this is for the gold. Then how we calculate? For the first color we see the figure. For brown 1. For the second color we again see the figure, that is 4. And for this last line, last color, we see the multiplier 10 raised to power 1 ohm. So this becomes 140 ohm. And the tolerance means this last color, that is gold, 5%. So this is the carbon color code relations, how we use this. And if we have the number 3 plus minus 10%, we say we give the colors also. For 1, this is brown. For 5, this is green. And for 10 raised to power 3, this is orange. And for 10%, we have the silver. So this is the color coding for the carbon resistance. And for this, we have to remember this table. And the next is combination of resistance. Combination. Resistance combination is of two types. Series combination and the parallel combination. Series combination where the resistance are connected one end, other end, other end, and to the battery R1, R2, R3, the current I. For series combination, this voltage remain divided and the current remains same. Here V1, V2, V3. You remember this. For series combination, voltage is divided but the current remain same. How we write the voltage? V1, V2, V3. So if this is the net resistance, this is I R1, this is I R2 and this is I R3. Then what is the resistance? That is R1, R2, R3. Means when the resistors are connected in series, net resistance ने बढ़ जाना, सब तो बड़े resistance तो भी ज़्यादा बड़ा होना. And in parallel combination, what we have? In parallel combination, voltage is the same, but the current is divided in parallel combination. For the parallel combination, you have to remember this. This I is I1, I2, I3. So this V is IR, so I is equal to V upon parallel R1, R2, R3. So how we get the parallel combination? 1 upon Rp, 1 upon R1, 1 upon R2, 1 upon R3. So in series combination, total resistance increased, and in parallel combination, total resistance is decreased by the reciprocal. Next term, we have internal resistance, EMF, and the terminal voltage or the potential difference. That is, next topic is internal resistance, EMF, internal resistance, EMF, and terminal voltage for cell. Internal resistance. For the cell, we have electrolyte solution, and the resistance offered by the electrolyte is called internal resistance, R, denoted by R. It is not the defect of the cell. It is the characteristics of that cell. For freshly prepared, internal resistance is very small. But when the cell is in used, ਜਿਵੇਂ ਜਿਵੇਂ cell ਨੇ ਕੰਮ ਕਰਨਾ, current deliver करना, the internal resistance ने बढ़ना. But it is not called the defect of the cell. Keep remember this. And EMF. This EMF means electromotive force. Electrons ਨੂੰ move ਕਰਨ ਵਾਲੀ force. The potential difference between the two terminals of the cell in open circuit. ਜਦੋਂ cell current नहीं ਦੇ ਰਿਹਾ, open circuit ਦੇ ਵਿੱਚ ਦੋਨੋਂ ਜਿਹੜੇ electrodes ਨੇ cell ਦੇ, ਉਹਨਾਂ ਵਿੱਚ ਜਿੰਨਾ difference ਹੋਏਗਾ, potential difference, that is called the EMF of the cell, or it is the work done. EMF of the cell, the energy supplied by the cell to drive the unit charge. पूरे सर्किट च घुमाउण लई जिन्ना एनर्जी सप्लाइड आ, वर्क डन आ, दैट इज कॉल्ड द EMF force, joule per coulomb. Work done per charge, that is called the potential. Similar like electrostatic potential, we say that work done per charge. The same thing, work done per charge. And the terminal voltage, it is represented by E, and this terminal voltage represented by the V. V means potential difference between the two terminals of the cell when it deliver the current. ਜਦੋਂ ਇਹਨੇ current देना शुरू करता, that is called the terminal voltage. And this terminal voltage is always less than this IR. And when there is no current, the both are same. The both are measured in volt, joule per coulomb. But when it deliver the current, the potential drop across the internal resistance ਇਹਦੇ ਚੋਂ minus ਹੋਣ ਲੱਗ ਜਾਂਦਾ. And this is also called lost voltage. So the voltage potential drop across the internal resistance is called the lost voltage. Now how we relate these terms? ਅਸੀਂ ਇਹਨਾਂ ਤਿੰਨਾਂ ਨੂੰ relate ਕਿਵੇਂ ਕਰਨਾ, ਜਾਂ ਅਸੀਂ internal resistance ਦਾ expression ਕਿਵੇਂ ਲਿਖਣਾ? ਮੰਨ ਲਓ we have a cell and we have a battery key. It is connected to the external resistance R. Now its internal resistance is small r. We have a meter here which measure the voltmeter, which measure the voltage. When it is open circuit, this meter measure EMF, but when it is closed, it start giving the current. Then it measure the terminal voltage. How we write the current? EMF external plus internal. क्योंकि cell ते external series च लगे हुए ने, तो total resistance की हो गया R plus R. So what is the E? That is IR plus IR. We can write like this, IR. But This IR, according to Ohm's law, is the potential difference, voltage IR, and we found E minus IR, this relation, very important relation. V is always less than E. And if we use this relation, V is equal to IR, V, E over R plus R, then R plus R is E over VR, or small r is E over VR minus R, or we can say E over V minus 1 into R. So this is the expression for terminal voltage, that is E upon EMF, internal resistance. For internal resistance, this is EMF, terminal voltage, and this is called the external resistance. And for the next, we have grouping of cells. Cells ਦੀ grouping, ਜਿਵੇਂ ਅਸੀਂ resistance ਦੀ combination ਦੀ ਗੱਲ ਕੀਤੀ series parallel ਦੇ ਵਿੱਚ, ਉਸੇ ਤਰ੍ਹਾਂ ਜਿਹੜੇ cells ਨੇ ਉਹਨਾਂ ਦੀ ਵੀ ਅਸੀਂ grouping ਦੋ ਤਰ੍ਹਾਂ ਨਾਲ ਕਰਦੇ ਹਾਂ, series और parallel ਦੇ ਵਿੱਚ. But here we have some conditions. When we say grouping of cells in series, we have the two cases. First is when the same EMF, ਇੱਕੋ ਜੀ EMF ਤੇ internal resistance ਵਾਲੇ cell series ਚ connect ਹੁੰਦੇ ਨੇ. मान लो n cells ने, we have the n cells, और ये सारे external R दे नाल जुड़ गए, external R resistance दे नाल series दे विच जुड़े हुए ने, और इन्हां दी EMF सारियां दी E आ, और इन्हां ने I करंट डिलीवर करना n cells ने. हुण जिन्ने भी असीं EMF cells जोड़दे जावांगे तो total EMF कितनी, total EMF E plus E, how many times E plus E, that is n times Ne. ਹੁਣ resistance हरेक cell ਦੀ internal resistance R1, R2, R3 up to n. So total internal resistance, how we say R plus, क्योंकि series च resistance सीधी ही जुड़दी है, so this is NR. Now this whole internal resistance and this external resistance, if we say this one and this is the combination, means Ne NR, and it connected with this external R. So total resistance, that is R plus NR, and the current is total EMF upon total resistance. This is the current for this combination. Now we have the two conditions. जेकर external internal तो बहुत बड़ी है तो ਅਸੀਂ ਕਿਹਨੂੰ neglect ਕਰਾਂਗੇ, जो छोटा term है वही neglect करांगे, तो current की बन गया Ne upon R, मतलब n times बन गया, और जे ये छोटी आ तो ਅਸੀਂ ਕਿਹਨੂੰ neglect ਕਰਾਂਗੇ, R ਨੂੰ neglect ਕਰਾਂਗੇ, ਤਾਂ ਫਿਰ करंट की बन गया Ne upon NR, n कट गया, मतलब single cell ਦਾ करंट बन गया. Means when we have the combination of cells in series grouping of cells and same EMF, same internal resistance, to get the maximum current लैण वास्ते external resistance की होना चाहिदा, बड़ा होना चाहिदा. And when we take the this is the same EMF A part, and when we have different EMF, ਇਹਦੇ ਵਿੱਚ ਅਸੀਂ ਦੋ ਸੈੱਲ ਦੀ ਗੱਲ ਕਰਦੇ ਹਾਂ, E1 E2 with resistance R1 R2 with internal resistance, and they are connected in series to send the current like this. Two cells to send the current E1 E2. Now in series combination, the same is current and the voltage is difference. Then how we write the voltage for this? If we have the internal resistance R1 R2, so jada relation पिछले पढ़े आसी, V1 is E1 I R1 and V2 is E2 minus I R2. Okay, current is the same, but the potential voltage, terminal voltage is different. Then how we write the total voltage? V1, V2, that is E1 minus R1, E2 minus I R2. Then E1, E2 minus I R1, R2, V. We can compare it, IR. So this is E1, E2 and this R is R1, R2. Means when the cells are connected in series with the same EMF, then to get the maximum current in that combination, external resistance should be large so that we get the maximum current. But when the different EMF are used in series combination, the total EMF is sum of the EMFs and the total internal resistance is sum of the internal resistance, and the current is E upon capital R plus R, means E1 E2 upon R plus R1 R2. So this is the series combination for the cells. And now the next one is a parallel combination for the cells. Parallel combinations. For parallel combination, again the same thing. First part, same EMF. For parallel, first is again same EMF and the same internal resistance. And when the cells, they are connected in parallel combination. This is the parallel combination. Say, deliver the current in this. Now we say that M cells, EMF E or internal resistance R, that is the same. Then फिर total EMF E plus E voltage आ parallel आ तो E ही रहेगी, and total internal resistance, internal 1 by R, 1 by R, 1 by R, M times M by R, but we have to take the reciprocal R by M. Total resistance ਜਿਹੜੀ ਆ external ली आ, ये internal आ, total resistance R plus R by M. This is the total resistance. And how we get the current? EMF R plus R by M. This is the total current. Here again we have the condition, जे R बहुत बड़ा RM नालों, तो ਅਸੀਂ ਇਹਨੂੰ ਛੱਡਤਾ ਤਾਂ करंट रह गया E by R सिंगल सेल जिन्ना, पर जे R छोटा इंटरनल नालों तो फिर ਅਸੀਂ ਇਹਨੂੰ ਛੱਡਤਾ तो करंट हो गया M E upon R M times. मतलब ये कंडीशन पिछले वाली कंडीशन तो ऑपोजिट होगी. पैरेलल कंबीनेशन दे विच जे मैक्सिमम करंट लेना ਤਾਂ इंटरनल रेजिस्टेंस ने ਜਿਹੜੀਆਂ ਉਹ ਵੱਡੀਆਂ ਹੋਣੀਆਂ ਚਾਹੀਦੀਆਂ ਨੇ, मतलब एक्सटर्नल छोटी होनी चाहिए है, बट इन सीरीज कंबीनेशन एक्सटर्नल बड़ी होनी चाहिए है. Now we have when the different EMF cells are connected in a parallel. Again we consider the two cells with E1 R1 E2 R2. They are combined in a parallel combination between the 2 points A and B, between the 2 points. But in this case, now this is a parallel combination, and for parallel combination voltage is same but the current is different. Then how we write the voltage is same, current is different. V for first cell I1 R1, so I1 R1 E1 minus V, I1 is E1 V upon R1. Similarly I2 E2 minus V R2. This is the second current. Now the total current is I1 I2 E1 minus V R1 E2 minus V R2. Then we have E1 upon R1 E2 upon R2 minus V 1 upon R1 1 upon R2, that is I. So we write here R1 R2 E1 R2 E2 R1 and minus V that is R1 R2 R1 R2 I ਹੁਣ ਅਸੀਂ ਇਹਨੂੰ ਰਿਵਰਸ ਕਰ ਸਕਦੇ ਹਾਂ V ਵੈਲਿਊ ਇੱਧਰ ਆ ਸਾਡੇ ਕੋਲ R1 R2 R1 R2 this is E1 R2 E2 R1 R1 R2 minus I and when we write this E1 R2 E2 R1 R1 R2 R1 R2 upon R1 R2 minus I R1 R2 upon R1 plus R2. So cancel. So this is E1 R2 E2 R1 R1 R2 and here minus I R1 R2 R1 plus R2. So when we compare it minus I R. So in the different EMF of cells in parallel combination, how we get the total EMF? By this. And how we get the total internal resistance? By this. That is the total EMF, total internal resistance. And the last of this is mixed grouping of cells. This is not the part of CBSE syllabus, but you just remember what is the mixed grouping of cells. Mixed grouping of cells means when the both types of grouping is done. We have again in one row we have n cells and how many rows? M rows. Then how many cells? Mn. In one row n cells and how many rows? M rows. ठीक है जी? And then in one row the total EMF is Ne. सारे Ne रहेगी. The total EMF that is Ne and the total internal resistance. Now how we get this internal resistance? ਹੁਣ ਇੱਕ ਰੋ ਦੀ resistance NR ਫਿਰ NR ਫਿਰ NR ਕਿਉਂਕਿ ਇੱਕ ਦੇ ਵਿੱਚ N cells ਲੱਗੇ ਹੋਏ ਨੇ ਤਾਂ ਇਹ ਰੋ 'ਚ ਲੱਗੇ ਹੋਏ ਨੇ ਮਤਲਬ 1 upon NR 1 upon NR 1 upon NR how many times? M times means M upon NR means R dash is NR upon M. So this is the total internal resistance and total resistance again external plus internal. Then the current is EMF upon NR then MNE upon MR plus NR. So this is again NE upon MR plus NR. Now we have the condition. In same EMF in series combination, external resistance should be large. And in same EMF in parallel combination, internal resistance should be small, external should be small, and in series external should be large to find the maximum current. So in this term should be minimum. And this term should be minimum when they both are same means R NR upon M. External, internal should be same to get the maximum current in mixed grouping of cells. So that's all for the first chapter of current electricity. Thank you.